So in this section about the unit circle, again I said that the unit circle is graphed on a x, y plane, your x-axis and your y-axis. Now looking at this one, this is the unit circle with the given degrees, given radians, and given exact value for sine and cosine. Now I mentioned how cosine is the x value and sine is the y value. So looking at this one, 30 degrees. If I were to ask you for cosine of 30 degrees, it'd be square root of 3 over 2. And if I were to ask you sine of 30 degrees, it would be 1/2. So before we can go into memorizing the exact values of the unit circle and its degrees with its corresponding radians, first we're going to go over how to logically connect the unit circle to what we know already from algebra and geometry. So here we have a blank unit circle. So let's talk about Quadrant 1. Here's Quadrant 1. Now keep in mind, this is the x-axis, this is the y-axis. So now we're not going to focus on these two here. Let's focus on these three, because these quadrants, these endpoints or the boundaries are easy to remember. So if we're trying to memorize, so let's connect dots. Let's name this one. Again, I mentioned how cosine data is x value and sine data is y value. So let's go to write our x1 and y1. My second one, let's say given an x value, so x2 and y2. And then our third one, x3 and y3. Now, the reason I wrote x1, x2, and x3 is because they're all three different x values. So x subscript 1, x subscript 2, and x subscript 3, again, it's a notation for different x values. Same thing with the y sub 1, y sub 2, y sub 3, three different y values. So what we're going to do is using just basic logical skills about distance. So for example, this is Quadrant 1. If I want to see a connection between Quadrant 2, so let's think about this. So I'm going to write in red. Now, here, this is 30 degrees. Remember, this is the standard position right here. That's where it starts. So, now, if I were to compare with Quadrant 2, so if this is a straight line, and if this was also 30 degrees, so then these two lines are somewhat related to each other. So again, if this is a straight line, and these two have the same angle of rotation, which is 30 degrees, alright, so if they're both 30 degrees, then somewhat these two lines are related. So I'm saying these 2 points, logically speaking, these 2 points are related. So let's think about that. So if I were to draw a vertical line here, so the distance, so the horizontal distance from this point, so if I were to compare it with the vertical line, this is my x1 distance, or distance of x1. Now again, we're using x1 because we don't know the value of it. Now, if I draw a vertical line here, Would it be the same distance? We're not sure. Let's check something out. So again, here's a straight line, both 30 degrees. So if I were to connect them, now if you look closely, what I typically do is see if they're parallel. If this line that I drew is parallel to the x-axis, so usually we check the distance, like with a ruler, see if it's the same distance. So basically 2 inches here, well actually an inch and a half here, inch and a half here, inch and a half here. So it's the same distance from the x-axis to the line. So that means that the line that I drew is parallel to this. So that means that wherever I am, it's going to be the same height. So my height is the vertical line. So my vertical line is going to be a height of y1. So if it's the vertical height is y1, then logically speaking, it would be the same amount of height. So y1 here. So if these two are the same height and it's 30 degrees, so just like triangles, then the length from the center to these points right here should be the same distance as x1. So logically speaking, if they're both 30 degrees, if it's the same height, then we can say that these two are the same distance, the horizontal distance. So if it's the same height, then I can logically say that this is also value of y1. Now, I can say it's positive because, remember, this is the x-axis, this is the y-axis. Anything above the x-axis, the y values are positive. Now, again, this is the center. On the right side of the center, the x values are positive. Now over here, we established that the x1 distance is the same. So therefore, we can also say that this is x1. But we have to keep in mind, since this is the left side of the center, all my x values are negative. So this right here is negative x1. So, establishing that, we were able to find the coordinate points from using this that we know to what we know here. So, since it's the same height, y1, and it's the same distance from the center, so this is x1 because it's in quadrant 1. This is negative x1 because it's in quadrant 2. Alright, let's talk about the other one, the second coordinate point. Now, if I'm using my knowledge, what I learned about these 30 degrees angle, now the second one, is 45 degrees. And let's say that this one is also 45 degrees. And then let's check. I'm going to connect these two dots. And then if I want to check if it is the same distance, so 2 inches and 1/8, 2 inches and 1/8, 2 inches and 1/8, 2 inches and 1/8, 2 inches and 1/8. Okay, so the line that I drew is parallel to the x-axis. So if it's parallel, then the distance anywhere I am is going to be the same distance or the same height. So let me draw a vertical line perpendicular to the x-axis. Now, if these two vertical lines are perpendicular, straight, so that means that they have the same height. So in this case, since we're talking about x2 or x sub 2 and y sub 2, if this is the height, then this height is the value of y sub 2. Now, if it's perpendicular, the vertical line, and the one I drew, if they're parallel, these two lines are parallel, then the two vertical lines that I drew that are perpendicular, if this is the height of y2, then I could say the same thing here. This is the height of y2. So, if they're both the same height, then this corner point right here is going to be the same height as the one over here. So, this will be y sub 2. Now, both angles are 45 degrees. Both have the same height. Now, if they both have the same height, then that means that the vertical, again, the vertical height is the same, then the horizontal distance from the center. So here, if I use this as my reference point for center, then the distance between these two right here is x2. Then my distance over here is the same amount, which is also x2. So my horizontal distance from the center to this point is x2. I can also say logically that this is also the same distance of x2 from the center to this point because they have the same angle measurement and the same height, the vertical distance. So I can say that this, my x-coordinate, is the same distance as x2, but remember, my x values on the left side are negative, so this will be negative x2. Alright, my third coordinate points. Now, so the third one is 60 degrees. And this one also 60 degrees. Now, if you want to find your angle measurement, you can always use a protractor. Now, this is my x sub 3 and y sub 3. So, if these two are 60 degrees, so let's draw our vertical line perpendicular to the x-axis. Same thing here. My vertical line perpendicular to the x-axis. Alright. Now let's connect the two dots together. See if it's parallel. Alright, so I want to check if they're parallel. So I would say 2 inches and 5/8 here. 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 So I can safely say that the line that I drew here, this horizontal line, is parallel to the x-axis. So if the blue line that I drew is parallel to the x-axis, then my vertical line that I drew will be the same height regardless of where I'm at. So regardless of where I'm at, it's going to be the same height here, same height here, same height there, here. So therefore my vertical line that I drew will be the same distance, same amount for height. So my blue line, if this is my vertical line, that means that my height is the value of y3. I'm going to write right here because we're running out of space. So if my vertical line is a height of y3, then on the other side, of the parallel lines, I can safely say that this is also the value of y3 for my height. So if this blue line is the same height as this one, then it would have the same y coordinate, so y3. Now, if I'm using this y-axis as my reference point for the center, so my center is right here. So if they have the same angle measurements and the same height, that means that the distance from the center to this point, which is x3, my horizontal distance, then, again, logically speaking, mathematically, if it's the same height, same angle measurements, then the distance from the center to this point is x3. I can safely say that this is also the same distance, x3, on the left side. So, if this is the value of x3 for the horizontal, then I can safely say this is the same distance. So therefore my x value will be x of 3, but since we're on the left side of the center, this is going to be negative. So, here I show you the connection from quadrant 1 to quadrant 2 in terms of these x values, these coordinates. So, knowing that, if you know your coordinates here, then therefore you know your coordinates there without knowing the radians or the degrees. But you would have to know your degrees, your radians, to know your exact value for quadrant 1. So before we can connect the dots between quadrant 1 and quadrant 2, you need to know the values for quadrant 1. So before, I mentioned to memorize sine of 0 degrees, 30, 45, 60, and 90. Then I mentioned to memorize cosine of 0, 30, 45, 60, and 90 degrees. So let's do 30 degrees. Now remember, if I were to do sine of 0 degrees, this would be 0. If I ask you to do sine of 30, again, there's a little mistake I made. Sine of 0, the y value is 0. I mentioned before that sine theta is for the y values. So sine 30 degrees is 1/2. And then cosine of 30 degrees is the square root of 3 over 2. And then cosine of 0, right here, 0 degrees, is just 1. Now, if this is 30 degrees from the x-axis, then from the previous picture that we did, then it will have the same y value, which is 1/2. So this would be the same height, same y value. And then it would be the same distance for the x value. So this would be square root of 3 over 2. But keep in mind, since we're on the left side of the center, this will be negative. So we figure out our corner point in quadrant 2. They both have the same y value, both positive. Here on the right side, it's a square root of 3 over 2, but on the left side, it's a negative square root of 3 over 2. Now let's do the second one. The second one is 45 degrees. And I can say the same thing here, 45 degrees. Now earlier, we're connecting the dots between quadrant 1 and quadrant 2. Now, if you recall from sine of 45 degrees and cosine of 45 degrees, so let's talk about sine of 45 degrees. Sine of 45 degrees is square root of 2 over 2, which is the y value because I did sine. Now, cosine of 45 degrees is also square root of 2 over 2, but that was the x value. So cosine is the x value. So, connecting the dots. So earlier we connected how it's the same height and same distance for the x value. So if there's the same height, then the y coordinate, the y value is the same. So square root of 2 over 2. Now, if it's the same distance from the center, then it has the same x values. So again, if they have the same x value, then this coordinate is square root of 2 over 2 for the x value. But remember, since we're in quadrant 2, the x value is negative, so this would be negative square root of 2 over 2. And then, our third one. If I were to do sine of 60 degrees, then the y value would be square root of 3 over 2. If I were to do cosine of 60 degrees, it'd be 1/2. Now, connecting the dots with this point, it has the same height, so that it will have the same y value, square root of 3 over 2. And if it's the same horizontal distance from the center, then it will have the same x value, which is 1/2. But since it's on the left side, it would be negative. So here, if you were just given this picture, you can easily label your exact values if you know your quadrant 1. So this one is 60 degrees. Now, so again, for 30 degrees, 45 degrees, 60 degrees. So let me label this in. This is 30 degrees. This is 45 degrees. And this is 60 degrees. So therefore, this is 0 degrees here, which is why we have the coordinate 1, 0. And up here is 90 degrees. So, if this is a unit circle, then if you look closely, if this is the center, keyword center, then all the lines here are the radius of r. So, now, tying back to when I had you review it, the exact value of sine and cosine, if I ask you, what's the sine of 90? You would say 1. And if I ask you, what's the cosine of 90? You would say 0. So here's a coordinate of 90 degrees, 0, 1. Now, here, we won't be using these degrees for quadrant 2 unless you're talking about reference angle. Now, if I were to ask you these degrees, these will be different values. So, let's connect the dots. So you see here in quadrant 2 is a right angle. If this is 60 degrees, then I can say that this is 30 degrees, because 60 plus 30 makes 90. So, if I'm trying to find out the angle measurements, it's basically, since this is also a right angle, so 90 plus 30, this will be 120 degrees. So if I ask you the value of cosine of 120 degrees or sine of 120 degrees, you will give me these exact values. Now, you can do what we did before if I give you this 120, what you did before, you would use the reference angle 60 degrees, and then you would give me these values, and then if it was cosine, you would tell me that it's negative, because from what we did before, I mentioned how all trig function is positive. Over here, only sine is positive. Quadrant 3, only tangent is positive. And quadrant 4, only cosine is positive. So remember the saying, all students take college algebra, or all students take calculus. So that's how it ties into this unit circle. Now, if I'm doing this, the black one, and this is 45 degrees, if I want to figure out the other half of the angle to make a right angle, this is also 45 degrees. So starting from this line, I'm going to add 45 to 90. This will be 135 degrees. So if I ask you, what's the exact value of 135 degrees, you would stop here. This is the terminal side, and you would give me the exact value for cosine and sine. Now here, if I want to fill in to make my right angle, this is 60 degrees, because 60 plus 30 is 90. So starting from 90, I'm going to add 60. This will be my 150 degrees. So if I were to ask you, give me the exact value of 150 degrees. So I start from here, go to 150 degrees, that's where I stop. Then you would give me the exact value for cosine, and then you would give me the value for sine. And then if we were doing 180, so 180, as you look here, they're horizontal to each other. So, and there's a straight line. Then I can safely say that they have the same height of 0. Let me put this is 180 degrees. They're the same height of 0, but remember, this is a unit circle. If that's the center, the same radius, same distance from the center is 1. But keep in mind, since we're in quadrant 2, it's going to be -1. So here, we were able to connect the dots between quadrant 1 and quadrant 2 in order to determine these values. So if you know your quadrant 1 exact values of 0, 30, 45, 60, then you can connect the dots to give me the exact values, and then you would just have to use logical math of what you call complementary angles from geometry. If this is 30, this is 60. If this is 45, that's 45. If this is 60, this is 30, because they all add up to 90. Then you're able to figure out the degrees of 120, 135, and 150. And this is 180 degrees because it's a straight line. So keep that in mind to memorize quadrant 1 in order to help you memorize quadrant 2.